Welcome to another math problem of the week. 5 region, same angle, and equal area. Let's talk about it. So for today's question, we are going to divide a circle into 5 regions using 4 segments as shown here, so that the angle ABC equals to the angle BCD equals to angle CDE, and let it be theta. Suppose the total area of the purple regions OA equals the total area of the green regions. We also find in degree the angle theta. And the options are A, 42, B, 45, C, 48, or D, actually there's no such angle. What do you think?
Pause the video now if you wish to solve it. Keep watching the video once ready.
Before we find the answer algebraically, let's look at an interesting animation and to get a feel what should be the possible answer. Now note that if we fix the position A, then B can be vary a bit. And the important thing is what we want to know what is the value of theta so that the shaded region is exactly half of the area of the circle. Now in this case, we let the radius to be equals to 1. So you can see that when theta equals to 45 degrees, then the sum of A1, A2 and A3 always is a fixed value. This will mean that the answer should be equal to 45 degrees. To solve this question, let us recall some property of a circle. We know that for a circle, say the radius r, then the area of the sector OAB equals to half r squared theta, where the angle here is theta. And then, let's say using the same circle with the same sector OAB and the same angle theta. What about the area of this segment? Area of segment AB is equals to half r squared theta minus half r squared sine theta. So let's look at this question again. Now can I have this circle? These are the segments. We know that each of these is equals to a theta. Now let's pass through the center, call the center O. Let this angle to be x. Then we are focused on how to get the area A1, A2, A3 and A4. We will do it one by one. Now with the center here, angle x, so this will be also angle x. And don't forget that this is angle theta. So now we are going to get the area of the segment which is indicated as A1. So note that the OAB is a sector and OA equals to OB. And therefore the angle OAB also equals to theta plus x, which means that the angle AOB will equals to 180 degrees minus double of theta plus x. And therefore the area of A1 will equals to, before that, without loss of generality, we let the radius of this circle to be equals to 1. Then it will be easier for our calculation. Recall the area will equal to half r squared theta minus half r squared sine theta. With r equals to 1 now, then this will equals to half theta minus sine theta. Now we go back to this. So it will be equals to half theta minus sine of theta. This is half pi 2 theta plus x minus sine 2 theta plus 2x. Now we are going to get A2. this is what we need to consider. This is x, and therefore this is x. So A2 will be everything here. Note that the angle COB will equals to pi minus 2x. The area A2 will be equals to half of the circle, which is equals to pi r squared over 2, minus the segment OCB, that is equals to half theta minus sine theta. Theta in this case is pi minus 2x minus sine theta. So it will be equals to pi over 2 minus half pi 2x minus sine 2x. Likewise, we are going to get the A3. So this is C and this is D. This is O. This is theta minus x. And therefore this is also theta minus x. So the angle COD will be equal to pi minus 2 theta minus x. Similar to what we have just now. So the area of A3 will equals to the area of half of the circle, that is pi over 2 minus half theta minus sine theta. Last but not least, we are going to get A4. So this is point D and this is point E. This is theta and this is theta minus x from what we have just now here. So this means that this also equals to 2 theta minus x. And therefore, the angle of COE will equals to pi minus 4 theta minus 2x. And therefore, the area of A4 will equals to half theta minus sine theta. So now we are ready and we need to combine all the value here. So the total area will be equal to the sum of A1, A2, A3 and A4. Then we just look at the term with pi. So from here we have half pi and half pi. But you don't get anything here because it cancels out. So what we have is only a pi. Then we also have a term regarding theta. So from A1 we have actually negative theta. So it's negative 1. From A2, we don't have anything with theta. From A3, we have a positive 1 with theta. And from A4, we have negative 2 theta. So this amount of theta that we have. Then we look at the term x. From A1, we have a negative 1x. From A2, we have a positive 1x. From A3, we have a negative 1x. And from A4, we have a positive 1x. That's good because we won't have x anymore. And finally, we have sine of angle in A1, A2, A3, and A4. And let us combine them here. So we have half negative sine 2 theta plus 2x. From A2, that is a positive half sine 2x, so sine 2x. And from A3, it is a positive also sine 2 theta minus 2x. And from A4, it is a negative sine 4 theta minus 2x. Now let us focus on this calculation. So this actually means that it will be equal to pi minus 2 theta, and there's no more x. And finally, this will be equal to half sine 2x minus sine 4 theta minus 2x and sine 2 theta minus 2x minus sine 2 theta plus 2x. If we use sum to product rules, sine minus sine will give me 2 cosine. Cancel with the half here, it will only give us cos 2 theta sine 2x minus 2 theta, and the other one will be cos 2 theta sine 2x. So this will mean that pi minus 2 theta plus cosine 2 theta sine 2x minus 2 theta minus sine 2x. Now, if theta equals to pi over 4, then the total area will equals to pi minus pi over 2. And the last term will equal to 0 because cosine pi over 2 is equal to 0. And this will equal to pi over 2, and it is equal to the area of half of the circle. Which means that when theta equals to pi over 4, this green region will be exactly half of the circle. And it means that there's also another interesting property to be observed that is regarding the square of the length. Note that AB square plus CD square will equal to BC square plus DE square. And for now, let's look at other people's solution. That's all for today's lesson. I'll see you again next time. Bye bye.